Example 2, part 1, we want to find the equation of the chord of contact of tangents drawn from the point P, 5, negative 2, to the parabola x squared equals to 12y. So from the equation of the parabola, right, x squared equals to 12y means that a is equals to 3, okay? That's fairly important. Our external point is given by 5, negative 2, so we should also be able to see that x0 is equals to 5 and y0 is equals to negative 2, right? So if we want the equation of the chord of contact, right, then we know that the standard equation for the chord of contact is given by x0 is equals to 2a times y plus y0. So in this case, x0 is equals to 5, so we've got 5x is equals to 2 times a, which is 6, times y plus y0, that's going to be y minus 2. So that's going to be the chord of contact for part 1. Now in this case, part 2, the chord of contact is produced to cut the directrix at the point Q. We want to prove that PQ subtends a right angle at the focus of the parabola. So taking the equation of my chord of contact, so we've got 5x bracket 6 lots of y minus 2, right? So that's going to be our chord of contact. If I just get a rough sketch out, right? Because the sketch will allow me to see what is happening. So this is a very rough sketch. So I've got y, x origin, and let's say we've got the parabola, x squared is equals to 12y. So like I said earlier, the focal length in this case is 3 units. So the focus is going to be 0, 3, and the directrix is going to be y is equals to negative 3. Now our external point is at 5, negative 2. So let's say 5, negative 2 is about here, okay? Roughly speaking, not drawn to scale at all. So if our external point is over here, our chord of contact, so first, right, if I think about this, the chord of contact is going to be this line over here. We're going to take the chord of contact and we're going to extend it until it comes down to the directrix. So when it comes down to the directrix, okay, this point over here is Q, right? And this point over here, our external point was P. And what we want to do is we want to show that P to Q is going to subtend a right angle at the focus. So if I join P to Q, okay, that's going to be the interval P to Q, right? So then I've got P to S, and then I've got Q to S. Okay, my diagram is probably not the best, okay, but I want to show that this angle over here is a right angle. Now to show that this angle is a right angle is not difficult, okay? The standard way of doing this is essentially just to find the gradient from P to S, okay? I need the gradient from P to S, and I also need the gradient from Q to S. And what I want is I want the product of these two gradients to be equals to negative 1. Okay, we already know where P is. So P is 5, negative 2. We know that S is at 0, 3. What we need right now is we need Q. Q is the point where the chord of contact, okay, meets the directrix. So in other words, for Q, I'm just going to take the equation of our chord of contact and I'm just going to solve it to be equals to negative 3. Okay, so for Q, I'm going to let y is equals to negative 3. So in other words, that's going to give us 5x is equals to 6 times minus 3 minus 2. Divide 5 from both sides. Minus 3 minus 2, that's just negative 5. Right? If I divide both sides by 5, I'm just going to get x equals to negative 6. So that shows that Q is given by negative 6, negative 3. So if I check out the gradient from Q to S, okay, take note that S is of course given by 0, 3. So the gradient of QS is therefore 3 minus 3 divided by 0 minus 6. Okay, so that's just y2 minus y1 divided by x2 minus x1, right? And that's going to be 6 over 6. So the gradient there is just positive 1. Then I need to check out the gradient from P to S. Okay, of course, take note that P is given by 5, negative 2. So I'm looking for the gradient of PS. Earlier, I looked for the gradient of QS, right? So the gradient of PS in this case is going to be 3 minus 2. Okay, that's y2 minus y1. over 0 minus 5. That's x2 minus x1. And we are looking at 5 over negative 5, which is negative 1. And what do you guys know, right? Gradient of PS times the gradient of QS, in this case, right? The product of the two gradients is equals to 1 times negative 1, which is negative 1. And what that shows is that PS is therefore perpendicular to QS, or in other words, PQ subtends a right angle at the focus, right? Because angle PSQ is equals to 90 degrees. Okay, so that's what we have for part 2.